Hi, welcome to this video. I'm Chuck, and in this particular video, we're going to look at computing the derivative of the natural log function using the definition of a derivative. Okay, so we'll start off with reminding you that the definition of a derivative is this. Primarily, it is a slope. You have a change in y over the change in x, but the difference here is that the step size, the distance between your two x values, is approaching 0. We're going to use the function f of x equals the natural log of x, and then we are going to substitute that into the definition of a derivative, which will give us f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h, which is the natural log of x plus h minus the natural log of x over h. At the start of this, we're going to wind up applying a number of properties from natural logs. Okay, our first step is going to be to rewrite the numerator. And remember, if you have a natural log minus a natural log, that's really the first argument, the x plus h, divided by the second argument, x, which gives us this natural log of x plus h over x, still all over h. The argument, the inside part here, can be rewritten as two separate fractions being added together. And from there, we can then simplify the first of these fractions. X over x is just going to be 1. And we have with us still the x, or the h over the x, as the second fraction here. All right, so where do we go from here? Notice the whole fraction is still all over h. This can be rewritten as 1 over h times the natural log. And then using one of the properties of natural logs, if you have a coefficient times the natural log, what that really means is that's going to be an exponent here. So our next step is going to be to rewrite this as the natural log of 1 plus x over h raised to the 1 over h power. All right, so at this point we have that limit at the top of the screen. What we're going to do is we're going to attempt to clean this up a little bit and put it in a slightly different format to move forward. We're going to let v equal to h over x. So this h over x here is going to be redefined as v. Okay, so that gives us then that v is equal to the h over x, or h is equal to v times x. Or we can invert both sides, and this gives us that 1 over h is equal to 1 over v times x. And we can take this fraction on the right-hand side and break it up into two factors, 1 over v times 1 over x. In some other places, books and elsewhere, you will very likely see this called n or some other term than v. I use the v because my h's and n's start to look alike, and I didn't want that to become a point of confusion. All right, so what we're going to do is we're going to look at this top line on the screen, and this h over x is going to be replaced by v. The exponent 1 over h is going to be replaced by this product of 1 over v times 1 over x. And when we do those substitutions, we then wind up with the limit that you see at the top of the screen here. Okay, so it's time to once again apply some of the properties for natural logs. If you have a natural log, looking at the top line, of something or other, an argument, raised to some power, that exponent can be moved out front. This means that we can move the 1 over the v, the 1 over the x, or both of them out front as is appropriate. Well, in this case, we're just going to move the 1 over x out front as a coefficient times the natural log. Because 1 over x is completely independent of our limit as v goes to 0, in other words, we're concerned about what's happening with v, and x is not affected. we can move the 1 over x out front. We can factor it out, and it just becomes a coefficient 1 over x times the limit as v approaches 0. We can now rewrite this limit of the natural log as the natural log of the limit. Okay, so what does that get us? Well, if you'll recall, the limit as v goes to 0 or h goes to 0 or whatever letter you want to use there, the limit as v goes to 0 of 1 plus v raised to the 1 over v power is the definition of e, actually e to the first power. So we can take everything that is inside this bracket, and that is just another way to write e to the first power. When we rewrite that as e to the first power, we now have, remember it was the natural log, so we have the natural log, e to the first power, and it's still going to be times the 1 over x. Well, when we simplify that, remember the natural log and e are inverse functions. They cancel, and it leaves us with just the exponent of 1. So we have 1 over x times 1, which is 1 over x. This then gives us the derivative that we're after. The derivative of the natural log of x is equal to 1 over x.